to heat to volt. Recycling heat, renewing power. A simple but a powerful idea. What if we could turn the heat we throw away into usable power? Today, we'll show you how we turn the waste heat from air conditioners into usable electricity. We are the team VJX, guided by our mentor, Ms. Kripali Sanghvi. The problem began when we noticed how different devices waste so much energy. We wanted to turn that waste energy into something useful.
Hotter, and the AC usage is increasing. But every AC that we use consumes a lot of electricity and pushes the heat outside, making electricity bills rise high and cities warmer. ACs simply remove heat from the indoors but don't reuse it. So the heat goes straight into the environment. This increases outdoor temperature, raises power demand, and increases carbon emissions. So while we cool our indoors, the world outside gets way more hotter. End up paying higher bills, cities become heat traps, electricity suppliers face more load, and the environment faces a long-term damage. This is a problem that impacts cost, comfort, and climate all at the same time.
The solution: air conditioners release a huge amount of heat outside and nobody uses it. Instead of letting that heat disappear into the air, we capture it, and at the same time we use the AC's wastewater to cool the other side. And this temperature difference is our power source. To do this, we use the thermoelectric generator modules, also known as the Peltier modules. One side of the TEG touches the hot compressor and the other side is cooled using the AC's wastewater. The difference in the temperature is what generates electricity. No external energy required. Our prototyping journey is as follows. Phase 1, designing. Phase 2, assembly. Phase 3, testing. And Phase 4, validation. This happens because of the Seebeck effect. When one side is hot and the other is cold, electricity flows automatically. So, we are producing power using heat that already exists and water that was already being thrown away. Heat to volt reduces the wasted energy, lowers outdoor heating, requires no extra power, and can be added to existing ACs. It's simple, efficient, and eco-friendly, turning something we ignore into something useful. This is a model of a split AC. This is the indoor unit and this is the outdoor unit. So when we start the AC, it creates a cooling effect inside the room, but it throws out the waste heat into the environment through the outer unit. It contributes to global warming. So, to overcome this problem, we have invented the heat to volt system. Now, let me show you a demo of how this system works. After I turn on the AC, the compressor also starts. Now, you can see the bulb glow. This is the result of our system H2V converting the waste heat from the AC into electricity that can be used by using the Seebeck effect. This is what our H2V system looks like from inside. There are 5 TEGs placed between 2 heat sinks and there is an LED bulb attached to it. When the heat sink attached to the hot side of the TEG comes in contact with the hot body of the compressor and the heat sink attached to the cold side of the TEG comes in contact with the cool wastewater of the AC, creates a temperature difference which ultimately results into generation of electricity by using the Seebeck effect. So we have generated electricity by using the waste heat and wastewater of the AC. This is how we have recycled heat and renewed power through our heat to volt system. Heat to volt creates electricity from AC's waste heat using no extra power at all. It helps reduce outdoor heating and lowers environmental impact.